Hello students, this is Professor Vivek Rawat from CSIT branch, Sagar Institute of Research and Technology. I am taking the subject of Computer Organization and Architecture in CSIT branch. I am preparing this video for all the CS group students. The topic is multiplication algorithm. So in this subject, we need to know about the processing of ALU. After the processing of ALU multiplication algorithm, we got the result in binary digit form. Okay, so here is the presentation in which I will show you the hardware implementation of multiplication algorithm with flowchart of the multiplication algorithm. This is a very important topic about gate preparation, and also it is very important question for RGPV exam preparation. So what is the question for RGPV paper? So question is explain the multiplication algorithm with its hardware implementation and flowchart, or the question is explain the multiplication algorithm with the flowchart of the algorithm. By the use of this algorithm, we need to calculate some numerical problem. So first of all, we need to discuss about what is multiplication. We all know about the process of multiplication. Suppose we want to multiply two numbers. One number is 23, one number is 90. So the multiplication process says first you need to multiply 9 in 2 and 3. After this multiplication, you need to multiply 1 into 2 and 3. After this, you need to add the both multiplication results and you got the answer 437. This is a very simple process for the multiplication. We used this process from our childhood. But how ALU perform this multiplication? We all know we have two numbers. One is called multiplicand and one is called multiplier. So we need to calculate this multiplication in the form of bits. This work done by the ALU. So before this multiplication, we need to know about the hardware implementation of the multiplication algorithm. So ALU, what is ALU? ALU means arithmetic logic unit. It is a part of CPU, central processing unit. Central processing unit having two important parts, that is control unit and ALU, arithmetic logic unit. So this all process work in ALU. Okay. So in ALU, we have some important factors, important hardware to calculate any kind of calculation. First of all, registers. What is the definition of register? We all know about register is a very small part of memory which carry the small part of memory. Two registers B and Q are used to store multiplicand and multiplier respectively, as register A is used to store partial products during multiplication. Sequence counter is used to store numbers of bits in the multiplier. Flip-flop. What is flip-flop? Flip-flop contain only one digit, that is the actually sign digit or carry digit. Flip-flop, the store sign bit of register, we require three flip-flops, A sign, B sign and Q sign. Flip-flop E is used to store carry bits generated during partial product addition. This is the theory part. You need to write this theory part in your RGB answer. So we directly go through with this diagram. In this diagram, you can see a B register. B register means it is called buffer register. Actually, B register means buffer register. Here you can see B register. Here you can see A register. Here you can see Q register. Okay. So in this multiplication algorithm, how you can save the digits, how ALU decide the which number go through with which register. Okay. So here you can see the 23 number. 23, it is a multiplicand. Okay. So multiplicand, we need to save this multiplicand number either in B register or Q register. It is decided by ALU or control unit. 19 is a multiplier. So here we go to save the multiplier B register or Q register. But here we need to assign the register to the multiplier and multiplier. So B register assigned for multiplier and Q register assigned for multiplicand. What is A register? A register is called accumulator register. We all know that in the process of any calculation in ALU, the process works in only accumulator. Suppose we want to add two numbers, one number saved in B register, one number saved in Q register, but the whole process will work in A register. A register doing the process for B register and Q register and generate the result and provide the result to the B register. Okay, so accumulator is a type of register which used to calculate all the processes of ALU. In the A register, we have A sign, B register having B sign, and Q register having Q sign. This is the sign bit of the particular number. If sign digit means minus or plus. So minus or plus denoted by 0 and 1. So if Q register having minus number, so that sign will be saved in Q sign. That is called QS. In the flow chart, you can see here AS, QS, and DS. In the flow chart, you can see the multiplicand is B and multiplier is Q. Multiplier value saved in Q register and multiplicand is saved in B register. Now, here is the sequence counter. Sequence counter means it is a sequence of multiplication digit numbers. Suppose 23, if we convert 23 into digits, so it is giving us the 5 digits 1 0 1 1 1 and 19 giving the 1 0 0 1 1. So in this example, you can see we multiply this 1 into whole 1 0 1 1 1. So we got the answer 1 0 1 1 with the help of this 1. Now we all know that we need to discard this bit and this 1 multiply with this whole number. So we got 1 0 1 1 1. We multiply this 0 to hold the numbers. So got 0 0 0. This 0 also giving us same number 0 0 0 and this 1 multiplied in this whole number. So it gives us 1 0 1 1. After the adding these all numbers, we got a product that is 1 1 0 1 1 0 1 0 1. This is the simple pen paper calculation with the help of digits or bits for the multiplication of 19 and 23. But ALU who work for this type of calculation, so ALU needs these the hardware implementation for the whole calculation. So here B register, Q register, A register, and the sign of B is BS, A register sign is AS, and Q register sign is QS. So now, what is E? E is called extended flip-flop here. Why we need to take the memory for extended flip-flop? Extended flip-flop means when we multiply two numbers, we have some carry digits. Suppose I multiply two numbers, suppose 12 and 10. So when I multiply this number, I have some carry numbers. So carry numbers, carry digits will be saved in E flip-flop, that is called extended flip-flop. And sequence counter means here, this one multiply in whole number, this one multiply in whole number, this 0 multiply in whole number, this 0. So this is the sequence 1, 2, 3, 4, 5. Here is the sequence counter number is 5. So this sequence will be done 5 times. Total 5 times this multiplication process repeat. Now, in this diagram, you can see the multiplicand will saved in B register, multiplier will saved in Q register. AS tends to QS, XOR DS. This is the whole calculation about the XOR gate. XOR gate will give the some digit answers with the help of this process. A means accumulator register. The values of A register will be start from 0. The extended flip-flop values will be start from 0. Sequence counter will be n or n minus 1. Means 1, after that 1, after that 1, after that 0, 0. So this is the sequence counter. In this process box pass the whole process to this diamond decision box. In this diamond decision box, you can see the QN value. What is QN here? QN means QN is called least significant bit of the Q register number. Okay, QN means least significant bit. So least significant. What is the meaning of least significant bit here? So in this diagram, you can see the Q. Q is multiplier. Okay. So what is the multiplier in this example? 19 is the multiplier. 19 is the multiplier. So 19 will be saved in Q register. So Q register having the value 10011. So this one is the QN here. This one is the least significant bit. And this one is most significant bit. Okay. So you need to remember this. For all the calculation examples, this is the least significant bit, and these bits will be judged one by one after the sequence counter. If Qn is equal to 1, then this flowchart go through this direction. If that least significant bit is 0, then it goes through this process box. So it is a simple calculation algorithm method. In next video, I will solve an example of multiplication algorithm. So I am stopping this video here, and you can take the screenshot of this first slide, second slide, third slide, fourth slide, fifth slide. This is the only theory answer. After this, I will tell you how we calculate the digit number with the help of this flowchart. Thank you.